All right, please welcome our next speaker, Sydnee Spruiell.
My name is Sydnee Spruiell, and I was a contact sport athlete. I played soccer from the time that I was around 4 years old until my sophomore year of college. During the course of my playing career, I broke my nose 3 times, I had multiple concussions, and no one ever told me the long-term risks of what I was doing. So I'm going to talk to you today about chronic traumatic encephalopathy in contact sports, a transdisciplinary approach. And since I've gotten really used to giving this talk, and I usually see eyes glaze over like a jelly donut, what that means is I study head injuries, and I use multiple methods to do that. So when people think of CTE, this is what they think of.
Up the middle screen to Adams. He got popped in the face. Mouth guard comes out, and they're asking for help right away.
Helmet right into his. They got 15 more yards to go before a first down or a touchdown.
That young man is Davante Adams. That was his second major concussion during the course of his 3-year NFL career. He was unconscious on the field for 2 minutes. He received medical attention for 48 hours afterward, and then he returned to play less than a week later. So why is that problematic? It's not actually the big concussive hits that are the only problematic issues that people have playing contact sports. Any injury that your brain sustains, including the small, mild, repetitive hits that you sustain playing things like football, those are cumulative, and they cause big issues long-term. So what does CTE look like in someone who has had a lot of mild, repetitive traumatic hits? This is advanced stage CTE here on the right. This is a normal human brain. So normally when I show people this image, they think you're trying to trick them. They're like, okay, so the one on the right is from someone who is really old, from someone who maybe the brain wasn't collected in the best way. Maybe it sat out on the sun because it kind of looks like a raisin. And the problem with that is both of these brains were taken from 50-year-old men. The difference is the one here on the right was taken from a football player who had a long, illustrious career as an NFL center, and the one on the left was from a normal person who had no family history of these tauopathies. So why does this happen? Tau protein is present in your brain normally. It's a structural protein, and so it sort of helps the microtubules and microfilaments of your brain stay normal. However, and we're not really sure why this happens, when you have these multiple mild repetitive hits, what happens is the tau protein hardens. And when it hardens, it causes the tau protein in the cells around it to harden. And that kills cells. It causes them to undergo what we call apoptosis, or programmed cell death. So you can see in this one it's significantly smaller. These cells have died. There's significantly less white matter. Here, what's called the corpus callosum has shrunken and actually broken in this individual. And so what's the problem with that? What does it look like when it's developing? The brown is what we're going to call the tau protein. That's the bad protein. This is stage 1, so this is the preliminary stages. In someone who's afflicted with stage 1 CTE, you might see difficulty balancing, difficulty concentrating on normal tasks. By stage 2, they might have a little more difficulty focusing. They might have some behavioral issues. They might be struggling to focus, struggling to balance. By stage 3, you can see it's a little more advanced, and it's actually reached down into the amygdala. I was at a conference in Boston yesterday, and stage 3 CTE was what Aaron Hernandez, who was 27, was diagnosed with. That's the youngest case in the history of the NFL that anyone has ever been diagnosed with this late stage CTE. So the other thing about stage 3 is when we start seeing impulsivity issues. We start seeing decision-making issues. We start seeing hyperaggression and explosive behavioral characteristics that have never been present before in these athletes. By stage 4, this might present like Alzheimerism in a patient who's never had Alzheimer's. It might present like Parkinsonism in a patient with no family history of Parkinson's disease, and it might present like motor impairment. So this patient, because of this advanced stage of CTE, would probably be wheelchair bound. They might forget their children's names. They might forget their own name. What's interesting about this work is that it was actually spearheaded by the wives of NFL athletes who complained of saying, my husband, who's 40 years old, can't find his car keys. And that's strange. My husband, who's 45, can't remember our children's names. My husband, who's 50, can't find his way from the car into the house when it's sitting in the driveway. So Boston University did a study where they had 200 participants. Around half of those played in the NFL professionally. The other half were contact sport athletes who played at a recreational level, including high school or college. These are people who have never made a dime off of football. 87% of those tested positive for some level of CTE. 99% of the NFL players tested positive for CTE, and 100% were symptomatic. So what is my research doing to help? We're testing, can we predict the likelihood of future concussions based on a couple of different models that are applied in health communications. The first is the health belief model. So we're testing in doctor-patient communication, where the patient is a contact sport athlete who has had previous concussions. What are their perceived benefits of applying preventative behaviors such as the heads-up mechanism? So the heads-up mechanism teaches athletes to tackle with their body rather than lowering their head. It's proven to reduce concussions. The other one is, sorry, just blanked. So there are a couple of preventative behaviors that we can have these contact sport athletes apply, and in a lot of cases, those are just not being communicated to them. So we're testing when patients perceive the severity of this condition, when we show them that the average age for NFL players of life expectancy is 54, where the national average is 78. What do they perceive the severity of CTE to be? What do they perceive their own susceptibility to be, since they've had prior concussions? And we all know, once you've had a single concussion, you're significantly more likely to get multiple concussions after that. The secondary approach that we're applying is coach-to-athlete communication. What the coaches are telling these athletes, what role does that play in their perceived cultural norms about self-reporting concussions? Because a lot of coaches don't know that there's a problem unless the athlete tells them, hey coach, I think I've had a concussion. Currently, we've done some studies that make people believe that there's a culture of resistance to self-reporting those issues. And ultimately, how can we predict the likelihood of future concussions? I did a study last year. I had around 100 participants of halfway split between men and women, and I was able to prove that the only thing that positively correlated with receptive attitudes about learning about CTE was understanding the equipment limitations. So athletes who understood that they weren't fully protected by their protective equipment, like a helmet, were more likely to want to learn about CTE. This is the second component of my research, and it's a biological approach. This is one of my test subjects. He's a tadpole. What you can see in this image is that Mr. Tadpole here, this is his brain stem, and this is his brain, and he has no skull. And the reason that that's really cool is because we can apply a multiple injury model to these tadpoles, and we can test for the tau proteins in their brain while they're still alive. And the problem with CTE that we've had up to this point is that you can't test it in athletes while they still are using their brains. We have to wait until we can get a tissue sample afterward. So what we're testing is, as the number of injuries increases and tau protein aggregates increase, does the swim pattern irregularity increase? Again, the conference that I was in Boston yesterday was really interesting and a lot of fun from a scientific perspective, but the most impactful thing that I heard while I was there was from the wife of an NFL athlete, Tom McHale. His wife Lisa got up and she said, the one thing that I wish that scientists and doctors and people who are so far removed from the seriousness of this condition, the one thing I wish I could communicate to them is never underestimate the ability of this disease to change the person that you love into someone that you don't recognize. There are 30 million young adults participating every year in contact sports. 5.6 million people every year in the United States are living with symptoms like these. So it's a public health crisis, and my research is trying to figure out how we can fix it. Thank you.